Hello students, today we're going to talk about section 7.4, similarity in right triangles. We have triangle XYZ, and triangle XYZ is a right triangle. YW is the altitude to the hypotenuse of XZ. YW creates two other right triangles. All right triangles in this picture are similar. So triangle XYW, that's a right triangle, and it's similar to triangle YZW, and that's similar to triangle XZY. So what I'm going to do when we do the next example is I'm going to call triangle XYW the smaller triangle, because it is the smallest compared to the three. I'm going to call triangle YZW, I'm going to call it the medium-sized triangle. So again, YZW, that's going to be the medium-sized triangle. And triangle XZY, that is a large triangle. So small, medium, large. Right. So given this situation, we want to complete each proportion. So again, remember, a proportion is when you have one ratio equaling another ratio. All right, so let's take a look at this first one. We have side D, and then, so they said side D to side C. Well, side D is actually part of the small triangle. So we're going to put small triangle here. Side C, if we look at side C, that's going to be part of the medium triangle. All right, and now what we're going to do is we're going to look at how is D. If you look at D and you look at the small triangle, D is the shorter leg. So we're talking about the short leg. And look at C. If you just focus on C, compare C, E, and B. C is the short leg. So in this first ratio, we're comparing the small triangle to the medium triangle, specifically short leg to short leg. Now let's look at this. Now look at the small triangle, side C. So small triangle, side C, isn't this the larger leg? So that's the large leg. And look at the medium triangle. Which is the large leg of the medium triangle? Well, if this is the medium triangle, that's the hypotenuse, short leg, that must be the long leg. So this is E. And make this the word long, not large. So that's the long leg. So the answer is E. Let's take a look at this. E. So if we look at side E, the only thing side E can be is the medium triangle. So here's the medium triangle. Let's look at B. B is part of the large triangle. All right, so now let's look at this large triangle F. Large triangle F is the hypotenuse. So if this is the hypotenuse for the large triangle, the medium triangle, the hypotenuse is B. So if we look at the medium triangle, the hypotenuse is B. Earlier we said that the medium triangle, this is the long leg. And if you look at the large triangle, B is the longer leg. Alright, next, let's look at F to A. So F to A, first, if we're looking at side F, we're looking at the large triangle. If you look at A, that is the small triangle. So to be more specific, F with relationship to the large triangle, that is the hypotenuse. So F is the hypotenuse, it's opposite 90. So this is the hypotenuse. And what is A? A is also the hypotenuse of the small triangle. So A is the hypotenuse. Look at A again from the large triangle. So large triangle, look at side A. So side A, large triangle, is the shorter leg. So look at small triangle. Small triangle, short leg is going to be D. So now we completed each proportion to make this true. Alright, example 2. It says to find the geometric mean between the pair of numbers. All it is use your proportion. This is going to be x, cross product property, x squared equals 40. We take the square root, x equals 4 times 10. Square root of 4 is 2, so x equals 2 square root 10. So that's the geometric mean. Part B, do the same thing. Put 3 over x equals x over 48. Cross product property, x squared equals 144. Take the square root, x equals 12. So that's it for examples 1 and 2. Example 3, let's discuss again the similarity in right triangles. So similarity in right triangles, we have a similar picture. We have triangle ACB, and it says if CD is the altitude to the hypotenuse of AB, we know that these triangles are going to be similar. So the geometric mean is the altitude squared. So CD squared equals AD times DB. Remember, if you add these two segments, it creates the hypotenuse AB. Alright, so now next example. It wants us to find x and y. So if we look at this picture here, x and y, x is here, y is here. So what I'm going to do is I'm going to use the formula that we learned up here. I locate the altitude. This is the altitude. So the altitude is going to be CD squared equals AD times DB. So that's what's set up right here. AD times DB. So if we look at CD squared equals AD times DB, CD is 6 squared equals 82. DB is x. So we have 6 squared equals 2x. Multiply, divide by 2, x equals 18. So that's where we got the 18. X equals 18. Well, to find what y is, if you just focus on this triangle, we have a right triangle. Now that we have two sides of a right triangle, all we do is use the Pythagorean theorem. So it's going to be 6 squared plus x squared equals y squared. 6 squared plus 18 squared equals y squared. Evaluate all the numbers. We have 360 equals y squared. What we'll do is we'll take the square root. So y equals 36 times 10. The reason why I want to use this combination is because 36 is a square number. The square root of 36 is 6. So we could take this out. 10 is not a square number, so 10 stays in the radical. So now we have 6 squared root of 10 equals y. So that's example 3. Again, the key to all this is identifying the altitude and the hypotenuse it's created with. All right, last example. Same thing, find x and y. Well, I noticed this piece here, this is the altitude and this is the hypotenuse. So the formula is altitude squared equals this segment times this segment. So that's what we did there. So it is y squared equals 4 times 12. Altitude, segment times segment, that was the hypotenuse. So y squared equals 48. Take the square root from both sides. So y equals the square root of 48. Again, factor 48 such that you're going to get a square number. 16 is a square number. So the square root of 16 is 4. What's left in the radical is 3. So y equals 4 square root of 3. Now that we know what y is, well, we can use, again, if you notice, this is a right triangle. We can use the Pythagorean theorem, where it's leg squared plus leg squared equals hypotenuse squared. And that's what we did here. 4 squared plus y squared equals x squared. We substitute what y is. So when you square 4 square root of 3, that's 4 times 4 is 16. Square root of 3 times square root of 3 is 3. So 16 times 3 is 48. When you combine these, 64 equals x squared. Again, take the square root. X equals 8. All right, so that's it for today. Thank you.